Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day questions on GeeksForGeeks for 29th March 2023. The problem statement for today is count the substrings. This problem is based on strings and data structures. Let's now open this problem to solve it. Let's go through and understand the given problem statement. The problem statement says, given a string S, the task is to count the number of substrings which contains equal number of lowercase and uppercase characters. So again, the one-liner problem statement, and that is pretty simple. Simply we have to count the number of substrings that contains equal number of lowercase and uppercase characters. Let's go through the given examples. First example is that the given string will contain geek, where G and K is small and double E are in upper caps. So here the output is 3. There are 3 substrings of the given string which satisfy the condition. They are GE, then G double EK geek and EK. So here in all these 3 substrings we can see there is equal number of lowercase and uppercase characters. So we have got 3 such substrings. In the second example, the given input strings contains Women's Day. Here DAY is in capital letters. So here the output is 4. There are 4 substrings of the given string which satisfy the condition. That means the equal number of lowercase and uppercase characters. They are WO, the nth day, NSDA, NSD. In all these 4 substrings, again we find the same thing. That means there is equal number of lowercase and uppercase characters. So I hope the problem statement is clear. So actually this is pretty simple question. So we will be solving it with 3 approaches. This problem statement will be solving with 3 approaches. In the first approach, we will use 2 loops. The function will use 2 nested loops to iterate over all the possible substrings of S. The outer loop iterates over the starting index of the substring. The inner loop iterates over the ending index of the substring. For each substring, the function counts the number of uppercase and lowercase characters and checks if they are equal. If they are equal, the function will increment the count variable. Then at last, the function will return the final count variable, which represents the number of substrings in S that contains equal number of uppercase and lowercase characters. Okay, so this will be our first approach. So let me code that. That means that code I prepared just to save time in typing. So I'll explain it line by line. So here this will be our first approach. So here what we are doing, first we are initializing a count variable to store the count of the substring which contains equal number of lowercase and uppercase characters. Then after that we are iterating over each character in the string S using index I. That means a for loop with index I. Then we initialize the variables to keep track of uppercase and lowercase characters that we are doing inside this for loop. That means each time the outer for loop will run, this value will be reset. Then we iterate over the each substring starting from index I. So initially if you are starting with G, then the inner loop will take care of from I to up to the last one. So this will be our brute force approach. So with 2 loops we are iterating over all the possible combination of the characters. So okay, then the inner loop it is iterating over each substring starting with the index I, and here in this one we check if the character at the jth index is of uppercase or lowercase. If it is uppercase, then we increment the counter of uppercase. If it is lowercase, then we increment the counter of lowercase. And at any point we see that if uppercase and lowercase becomes equal, then we simply increment the count. So this will happen for the entire loop. Firstly for all the iterations for the inner loop, then again the inner loop iteration will continue till the outer loop iteration completes. So in all these combinations we will see that how many such occurrences are there. If you look at this example, then when I will be equal to 0, then we will get 2 here, because one GE and another one will be GAAK. So we will get this one when I will be equal to 0. Next time when I will be equal to 2 here, then we will get this this instance where E and K will be there, because the J loop is starting with index I each time. So when I and J will be pointing to E, and in next iteration when J will be pointing to K, that time we will get the equal number of count. I hope this is clear. So this was the brute force approach. Let's try compiling this code. Oh, sorry, this is Java code. Let me copy it again. Actually, accidentally it was opened in C++ editor, but this is Java code. Yeah, so see, here we have got the correct output. Let's try submitting this solution. So here we can see we have got correct output, and all the test cases have been passed with the first approach. So here talking about this one, time complexity of this approach, it will be in the order of big O of n square, where n is the length of the input array string. This is because the algorithm iterates over each character of the string once, then iterates over each substring starting from that character. For each substring, it performs a constant time operation to update the count of uppercase and lowercase letters and check if the count is equal. Therefore, the total time complexity is proportional to the sum of length of all the substrings, which is in the order of big O of n square. So this was our first approach, first solution. Okay. Now what we'll do, we will try to solve it with second approach. Second approach will be using dynamic programming approach. So in that approach, we will use 2D array to keep track of the differences between count of uppercase and lowercase letters for each substring. DP and the DP array element represent the difference between the count of uppercase and lowercase letters for the substring starting at index I and ending at index J. Okay, so we'll be using that 2D array in dynamic programming approach. Let's see how that code will be. So I've copied it here. Now let me replace this code. So here in all the approaches, I have tried giving comments so that it becomes easy to understand. So here, if you can see what we are doing here, then see, as I've explained, this will use 2D array that will be with the name DP. So what we are doing, it will first initialize that DP element first here. First we are creating this DP array and of the size of n plus 1 n plus 1. Then when the algorithm starts over this array, then what we do, we initialize the diagonal element of DP with 1. Diagonal element of DP with 1 if the corresponding character in S is in uppercase, and minus 1 if it is lowercase. Then it iterates over the remaining elements of DP and computes the difference between the count of uppercase and lowercase letter for each substring using the formula of DP of ij plus is upper functionality of S of the characters at j, and again it will return the same thing as plus 1 and minus 1. This one. If DP of ij is equal to 0, then the substring starting at index I and ending at index j has equal number of uppercase and lowercase characters. That's why it will increment the count variable. Finally, the function returns the count variable, which represents the total number of substring which have an equal number of uppercase and lowercase letters that we are returning here. And to check this is upper functionality, so we are checking that character dot is uppercase. This is the utility function created to check what is that whether the character is in uppercase or lowercase. So based on that only we are utilizing this. So we are using this at two places. Okay, so this was our dynamic programming approach. Let's compile this code. So here we can see we have got the correct output even for this. Let's try submitting this solution. So here you can see even with this solution, with this approach, we have got the correct solution. That means all the test cases have been covered. So here talking about the time complexity in this approach, here also it will be in the order of big O of n square, because n is the length of the input array. This is because the algorithm uses the 2D array to store the count of uppercase and lowercase letter for each substring. It iterates over the characters of the string once, and it iterates over each substring starting from that character. For each substring, it performs the constant time operation to update the count of uppercase and lowercase letters and check if the count is equal. Therefore, the total time complexity is again proportional to the sum of the lengths of the all substrings, which is in the order of big O of n square. So this was our second approach using dynamic programming. Now what we'll do, we'll go and now we will solve this using our third approach. So the third approach will use a hash map to keep track of the number of substring with a given difference between the count of uppercase and lowercase letters. Okay, so here we will be using hash map. So let me take that code. Let me replace this. See, actually this solution will be the optimized ones among all these three approaches. So here in this approach we will be using a hash map. So we will be using hash map to keep track of the number of substrings with a given difference of the count of uppercase and lowercase letters. What we'll do, first we'll initialize the hash map with a single value pair of 0 and 1 to represent the empty substring. It then iterates over each character of hash and update the difference variable to represent the difference between the count of uppercase and lowercase characters to index to the current index. If the hash map contains the difference key, that means the variable whatever we have used this, if it is already present in that one, then there must be a previous substring with the same difference between the count of uppercase and lowercase letters. The function increments the count variable by the value associated with the difference key, with the diff key in the hash map. It increments the value associated with the diff key in the hash map to indicate the occurrence of the new substring with the same difference between the count of uppercase and lowercase characters. Finally, this function will also return the count variable, which represents the total number of substrings that have an equal number of uppercase and lowercase characters. So here this was our the approach using hash map. So here we are just storing the difference here. If it is uppercase, then we are incrementing by 1. If it is lowercase, then we are decrementing the difference by 1. And we are checking in count if that map already contains this. If it already contains this, then we try to get it and we increment the value of count. If it is not present, then we will put it in the map with that difference variable, and we'll try to see whether if it is already present, then update the value by 1, and if it is 0, that means if it is coming the first time, then the count will be 0 here, and that will be incremented by 1. I hope this is clear. So talking about the time complexity of this solution, it is in the order of big O of n only. So here where n is the length of the input string s. This is because we iterate over each the character of the string exactly once, and the time complexity of insert, lookup and increment is big O of 1 on average. So this will be the most optimized solution. I hope this solution is clear. So here we are initializing the map, then we are counting the difference based on the value of uppercase and lowercase, and we are just checking in the map if the value is there or not, or what is the count of that. and whenever we are getting this this is already present, then we update the count and we return that. Okay, so let's try compiling this code. So even for this we have got this correct output. Let's try submitting this solution. So here we can see even this solution is the correct one, and we see we have got it in very less time. Okay, so yeah, so because this was in the order of big O of n, and here see, here we are not seeing that much difference, because that example here here that might not be that long. Yeah, but we are getting it with all the output correct with all three approaches. Yeah, but this will be the most optimized one, because it is in the order of big O of n only. So so this was all three Java solutions. Let me try giving the same solution, this HashMap one, using C++ code. So I'll first remove this one. You know, earlier by mistake I have copied Java code here. So for that I'll copy this one. I'm just writing one, just giving one solution which in C++, that would be for the HashMap one. So the equivalent code in C++ will look like this, where we create a map and we are again doing the same thing. If it is upper, then we are incrementing by 1. If it is lower, then we are decrementing by 1, and we are checking if that map contains already the difference 1. Then we get the value from the map for that particular difference and we add it into the count, and at last we return the count variable. So let's try compile this C++ solution. So even for this we have got correct output. And even here we can see we have got all the test cases covered, and out of all these four solutions, this C++ solution, this was very fast, which took only 0.02 seconds here, that very less time. Okay, so here we tried using solving this problem with in two languages. First three was related to Java and this one was C++. That's why we are getting 4 submissions here. Okay, so I'll provide the link for this question in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.